Yeah. Let's take that real quick. All right, cool. So, any questions? Go ahead. Wait, wait, hold on one second. So I heard square root of 2x. Is that all under the same square root? Like that? Okay. Oh, sorry. This thing does that from time to time. All right. Sorry about that. All right. Uh-huh. 3 x minus 1 like this. So long, huh? Yeah. So long story short, just square both of them, right? Because I want to get rid of the radical. Wow. Sure not. What the hell? My thing not working. All right, we'll worry about that in a second. All right. So you're just gonna square both of them just like this, right? So over here, when I square this, the radical and the square will cancel out, leaving back just 2x plus 1. On the other side now, right, when I square this, everything gets squared. So 3 gets turned into 9, right? Because that's 3 squared. And then whatever's in the radical just comes out. So x minus 1, just like this. And then after that, just distribute and solve for x, right? So I'm going to distribute this. Mm-hmm. So this is 2x plus 1 is equal to 9x minus 9. And then you just solve for x. That's simple, right? So I'm going to subtract 2x from over here. What I do to one side, you know, I got to do to the other, right? And I'm just going to add 9 over here. What I do to one side, do to the other, right? So now what do I have? I have 10 is equal to, I think, 7x. And then you just want to divide by 7, yeah. And then that's it. That's your answer. All right. And yeah, you should plug it in and verify, blah, blah, blah. But I know you're just doing it for homework. So if it works, then you know it works. Yeah, 10 over 7 for this question. All right. Any other questions? Go ahead. 2. Like this. Stay. Wait, like here? Like this? Parentheses. Oh, you mean like minus, like this? Got you. All right. Okay. Z? 0. Oh, so you just gotta solve for n? That's not bad. So just add 9, right? Because you want to put all your numbers on one side, get all your variables on the other. So I have 2 square root n is equal to 9, right? Then I'm gonna divide by 2. What you do to one side, you do to the other, right? Just like that. So now I have square root n is equal to 9 over 2, right? And then you want to get rid of that square root that's there, right? So you're just gonna square it, right? And that right, what you do to one side, you do to the other. Exactly. Right? So now what do you have? You have n is equal to, what's this? 81 over 4. That's it. Mhm. Yeah, we graduating in today's lesson, man. We're doing big things today. Yeah. 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 I'm gonna be excited what you see, especially you. Like, it's for you actually. It's not. Like this whole lesson is just for you actually. Any other questions? Or are we good? All right. I'm down. All right. We could start the lesson. This is gonna be so dope. Like for real, for real. But you know, before we start, I like to do a little blast from the past real quick. All right. Oh no, no. How I do this again? I forgot. Distribute, right? So I'm gonna do this times this. So x times 2x, what's that? No, 2x squared, right? I was about to say 3x. See, y'all corrected me. I forgot. Right? So x times 5, what's that? So plus 5x, right? All right. Now I have a negative 3 times 2x. What's that? Negative 6x. Very good. All right. Now this is the hard one. I got a negative 3 times a positive 5. What's that? Negative 15. Awesome. Awesome. And what do I do after that? All right. So what's the answer? Negative x, right? And then minus 15. Good. Yep. Very good. All right. All right. Just to bite off y'all homework questions a little bit. How do I do this one? For real? Yeah, I want to rationalize the denominator. How do I do that? Mhm. Mhm. So square root 5 minus square root 3. So what's illegal here? The something in the denominator, what? Mhm. The radicals, right? It's illegal for me to have radicals in my denominator. So how do I get rid of the radicals in the denominator? All right, I multiply by the conjugate, right? Conjugate means opposite. All right, so what's the opposite of the denominator here? Mhm. Uh-huh. Exactly, right? And what you do to the bottom, you do to the top, right? So square root 5 plus square root 3. Just like that, right? Yeah. And then after that, you just distribute, right? We know how to do that. So square root 25, good. Plus square root 15, very good. Over square root, let's say square root 25, right? Plus square root 15 minus square root 15 minus square root 9, right? And then what do I do after that? Okay, these cancel out. And then let's simplify these, right? So what's the square root of 25? 5 plus what? 5 plus, hold on, square root 15 over, what's the square root of 25 again? 5 minus, what's the square root of 9 again? 3, right? And what's 5 minus 3 again? 2, right? So this is 5 plus square root 15 over 2. And that's my answer. Yeah, question's real. That 5 minus 3, I was like, I mean, I ain't gonna lie, like I have my fingers up. I was like, yeah, I be doing that all the time. Like, I be in a supermarket, like, this carton only got 6 eggs. Pull out the chain, Nah, for real, I haven't carried cash in years. I don't even remember which presidents are on which money. You know, like, it's bad.
What's it, Benjamin Franklin?
Benjamin Franklin's 100, yeah. This is rationalizing the denominator.
How did you put the 5 + 16 on the bottom? So what do you do when you have everything canceled out?
Oh, like when you
25.
add them, that's what cancels them out. It's like positive.
No,
square-
I get
yeah.
that, but 25 and 9 at the bottom, what happens there? You square root it?
Yeah, so the
Five.
square root of 25 is 5 and the square root of 9 is 3.
Okay,
But the 9 is negative, see? So that's how I get the minus here.
the square root of 25.
Yeah.
25. Okay. Oh, why does the 15 say that?
There's nothing I could do to that. Yeah.
We can do the three
Mhm.
times.
3 times 5? Why?
Square root of 5.
Oh yeah, that's how I get square root of 15. 3 times 5. Yeah. Yeah. And then that's it. So all right, let's look at what we're getting into today. This is gonna be lit. Right? So we ripping the Band-Aid off today now. So we about to evaluate the square root of a negative number. This whole time I've been lying to y'all, telling them that it's not possible. Well, it is, right? So check this out. Whenever we have a situation where we have a square root of a negative number, we say that there is no real number that equals that square root. So for example, to simplify the square root of -1, we are looking for a real number x so that x squared is equal to -1. Since all real numbers squared are positive numbers, there is no real number that equals -1 when squared. Mathematicians have often expanded their number systems as needed. They added 0 to the counting numbers to get the whole numbers. When they needed negative numbers, they added negative numbers to get the integers, right? When they needed the idea of parts of a whole, they added fractions and got the rational numbers. Adding the irrational numbers allowed for numbers like, for example, the square root of 5. All of these together gave us the real numbers. And so far in your study of mathematics, that has been sufficient. But now we will expand the real numbers to include the square root of negative numbers. We start by defining the imaginary unit I as the numbers whose square is -1, right? So the reason why this is all for you, right? This is how we model electricity.
And truck too.
Yeah.
Electronic trucks.
So imaginary unit. So the imaginary unit I is the number whose square is -1. So it's like so look, I squared is equal to -1, or I is equal to the square root of -1. Remember that. I is equal to the square root of -1. All right? That's important right there.
Last lesson I had.
Nah, I promise you, this is light. I'll show you. All right, let's just add on to that. So the square root of a negative number, if b is a positive real number, then the square root of -b is equal to the square root of b times I, right? Now, me personally, I don't like to write it like that, but we're gonna talk about that. We're gonna talk. Right? Let's talk about that real quick before we jump into an example. All right, so we will use this definition in the next example. Be careful that it is clear that the I is not under the radical. Sometimes you will see it written as the square root of -b is equal to I square root b to emphasize that I is not under the radical, but the square root of -b equal to the square root of b times I is considered the standard form. Me personally, I go with this middle form right here. Square root of -b is equal to I square root b. Go ahead. As the other one. Yeah. is not. It's not supposed to be under the square root.
Yeah, but outside.
Right. Right, yeah. So I'm pulling the I out, basically. So the I is the -1. I'm taking that out of the whole problem. That's what that is. Yeah. And that's what we call our imaginary unit. I, yes. I for imaginary. So let me show y'all an example real quick what I'm talking about right? This is called complex numbers. Oh, that's another thing, right? So we going from like regular numbers to complex numbers. Yay. So check this out, right? Let me look at A, for example. So A is what? The square root of -25, right? If this was our homework, the answer to that would be not real, right? So what I'm gonna do here, right? I'm gonna separate this, just like how we did before, right? This is gonna be the square root of -1 times 25, right? Now, what I'm telling you is that the square root of -1 is I, right? This thing right here is I. And I forgot, what's the square root of 25 again? 5, right? All right. Whenever we write these together, we always put the number first and then the I. So the final answer here should be 5I. Mm-hmm. And then that's it. Mhm. If I was looking at B, like it's simplified. Oh, it's not real. No. Yeah. The whole time I've been lying. There's actually something that it is. That's called imaginary numbers. Yeah.
So basically, that's just something you get square root of 25, make it negative.
Mm-hmm. So you get 5I. Yeah. Yeah. So look at B now, right? B is a little more complicated. This is the square root of -7. Now there's no perfect square root that goes into 7, right? So how I would want this answer, I would say no, I square root 7, right? Just like that. Right. I is the -1. Yeah. No. We're gonna get to that. Yeah, we're gonna get to that. Yeah, that's coming. That's coming. Yeah. All right. And how about C now, right? C is the square root of -12, right? And then we have a perfect square that goes into that, right? Yeah, this is like what, square root 4? Wait, no, I'm sorry. I made a mistake. -4 times square root of 3, right? So this will become what? 2I square root 3. So square root of -4, right? Is not just 2I,
Because of the negative.
right? Because of the negative that's there. Right? Just like how square root of 25 became 5I. Mm-hmm. And then square root 3 can't get simplified, so that just stays there. Yeah. Which X? Oh, that's a multiplication sign. That's what I meant. Yeah. Or it could be a dot if you want, whatever. Yeah. So yeah, that's the secret right there. That's the sauce. Yep. Yep. This is it. I mean, once you learn this, like the rest of it is just some variation of it. So you guys try. Number 1 is really hard. Really? Sun is out? So I'm walking over here, right? I'm having a good conversation.
So it's
And
called-
then it's like the trees just start moving. And I'm like, why they moving? You know? And all of a sudden it starts raining. I'm like, what the heck?
Yeah, that's why I left 30 minutes early.
Yeah. They got floods in Canada? Yeah. Mhm. They didn't come here. How you go to Canada? Man. Dang. Nah, but when was this? Was it last year or the year before that, right? We had that when all the forests in Canada caught fire and came down here. Like they need some water up there because how is Canada on fire? That don't even make sense. You know how much snow they get? That don't even make sense. Yeah, that don't make sense, man. Yeah, I saw this one picture online. I should have known better, but like, yo, I swear, it was a picture of Manhattan with all the red dust, and I'm telling you, Godzilla was in the picture.
Hold on, Chris.
See? For no, wait, for the first one?
Yeah,
What's the square root of 81?
that's not.
Just plain 9.
Oh, you don't have to break it down though?
That's it. My fault. That was weird. Okay. On homework. It wants to give you too many questions, so I was like trying to cut it down, you know? Yeah, so I was just like delete, 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 you know? All right, so for A, what's the answer? 9i, very good. Ooh, this one's hard. What's B? Good. Hmm? Yeah, yeah. Just keep the square root, put the I in front, because we just get pulling out the negative for that one.
Just leave your,
Hmm?
your explanation of
Hmm? Yeah, that's it.
put it like I screwed nine. So
Nah, just 9i.
that work though?
Hmm? Yeah, it'll work for web work and all that. How about C? C's a little hard. Right. 3i square root 2. Right? That's it. Any questions on that? Everybody got that? You get negative 18? I got you. So, mhm. You could. I don't like that though. Cause like you have to be like really, really good the way you draw it to make sure that it doesn't look like it's underneath the radical, you know? Because if you do something like this, like that's super wrong, you know? So I just to be sure, that's rather it go like this. All right, real quick. Square root of negative 18, right? I'm gonna break this down to the perfect square, right? So this is gonna be what? Square root 9i times square root of 2, right? And excuse me, I'm sorry, I didn't mean to write that. Negative 9, right? So square root of negative 9 times square root of 2, right? And then the square root of negative 9 we know is what? That's the 3i. And you just keep the square root of 2, and that's it. So yeah, I made a mistake. Yeah, it be like that sometimes. All right, so let's talk about how we're supposed to write these numbers. All right. So now that we're familiar with the imaginary number I, we can expand the real numbers to include imaginary numbers. So the complex number system includes the real numbers and the imaginary numbers. A complex number is of the form a plus bi, where a b are real numbers. We call a the real part, and we call b the imaginary part. All right. So we need to remember this: a plus bi, right? That particular form. All right, and that's how we're gonna write our answers. Make sense? That didn't sound too good. Let me do it one more time, right? So a complex number, right? A complex number is of the form a plus bi, where a and b are real numbers, right? A is the real part, and b is the imaginary part, right?
So what, eight would be like 7 or something.
Exactly.
B would be 5.
Right. So like 8i or something. Yeah. All right. Make sense? Dang, nobody said that. All right, one more time, one more time. So a complex number is in standard form when written as a plus bi, where a and b are real numbers. If b equals 0, then a plus bi becomes a plus 0i, where a is a real number. That's what we're used to, right? If b does not equal 0, then a plus bi is an imaginary number, right? Now, let's say a is equal to 0, right? Then a plus bi becomes 0 plus bi, right? Where which is equal to bi, and it's called a pure imaginary number, right? There we go. So this makes sense, right? All right, let's try it again. Let's try it again. Let's try it. Got a whole chart for you now. Yeah.
Yeah, like 4 different examples.
Yo, I told you this lesson for you. You know? So this is A plus BI right here, right? So when B is equal to 0, right? A plus 0 times I is just A, and that's a real number, right? When B does not equal 0, then A plus BI is an imaginary number. And when A is equal to 0, 0 plus BI is just BI, and that's a pure imaginary number.
I had it before you just kept going as over.
For real? All right, all right. Let me try it again. Let me try it again.
5? That's crazy.
Yo, I told you, this is your lesson right here. It's for you. All right. This is the one thing you got to walk out of this class with. All right. So the standard form of a complex number is A plus BI. So this explains why the preferred form is the square root of negative B equal to the square root of B times I when B is greater than 0. All right. So we good?
You gotta see it like the actual numbers, probably.
So I got you, man. I got charts today for days, man. I got you. Got you right here. All right, so think of it like this, right? So for a real number, right? We have A plus BI where B is going to be equal to 0, right? For an imaginary number, like in A plus BI, B does not equal 0, right? Put them together, you get a complex number, A plus BI, right there.
Okay, so it's regular number plus the imaginary.
Exactly, exactly. All right. All right, let's talk about little operations real quick before we even get into an example. So I want to add or subtract complex numbers, right? So we are now ready to perform operations of addition, subtraction, multiplication, and division on the complex numbers, just as we did with the real numbers. Now, adding and subtracting complex numbers is much like adding and subtracting like terms. We add or subtract the real parts and then add or subtract the imaginary parts. Our final result should be in standard form. Now, what's standard form again? It's right here. Right here. A plus BI. That's standard form, right? That's standard form right there. All right, let's try this out. Huh?
What they use it
Electricity.
for, like what for?
Like this is how you model electricity, like the current that goes through the wire stuff.
Like numbers, imaginary.
Mhm. Yeah. Mhm. So that we want to add the square root of negative 12 plus the square root of negative 27. Help me out. What's the square root of negative 12? What's that going to be? Mhm. So this gets broken down to what? Square root, right? Negative 4 times square root 3. So that's like what? 2y square root 3. And then square root of 27. Negative 9. And then square root of negative 9 is square root of 3, right? So what's that? Like, exactly, right? Now, I'm looking at it, right? They both got i's, they both got the same index, they both got the same radicand. I could add these together, right? So what's my final answer? Exactly. Exactly. That's it. Yeah. Go ahead. Oh, the 3i?
I'm just breaking down that.
Yeah. So it's a square root of negative 9. Right? So the negative is I, and then the square root of 9 is just 3. Yeah. Right. And then the square root of 9 is 3. Oh no, this one is just carries down. I can't break that down because 3 is not a perfect square. Yeah, so I just leave it. That's it. Yeah. But not bad, right? That's all adding and subtracting is. You guys try. Just break it down. Then add it.
It's the same thing as before.
Mhm. Mhm. Not four. Oh. Four times. Yeah, it's like square, yeah, n squared minus, what's that, like 10n or whatever,
10.
yeah, plus 25, FOIL it, n minus
Oh.
1, and, yeah. Hold on. See? That's good, yep, that's good.
Tell us on these numbers. Sheet or.
Mm-hmm. Like for your homework?
Yeah.
Yeah, like for your homework, yeah.
That's great. This is engineering too.
Mm-hmm. Into this, like you solve for it? So just type it in. You're gonna get two answers, right? Yeah, so move that over.
This?
Yeah, well, no, this shouldn't cancel. -5 minus -5 is -10.
What is positive?
Yeah. Then just move the 16 over and then factor it, get the two answers and type it in. think it's 10 maybe. Okie dokie. So let's break this down, right? I have square root of -8. So I'm thinking square root of -4 times square root of 2. And for 32, I'm thinking, right, square root of -16 and square root of 2, right? So then this becomes what? 2i square root 2, bring that down, plus 4i square root 2. Huh? 60. Yeah, because 60 is a perfect square.
That
Yeah.
-8 square root 4. Then I broke it down to.
That's fine. Keep breaking it down if you want to do that. Yeah. Yeah. You can keep breaking it down. As long as you get the same answer, we good. All right. So 2i plus 4i, 6i, square root 2. And that's it. Yeah. So questions on this, anybody? No. Four is the square root of 16. Yeah. So that's it.
Right, it's the same thing.
Mm-hmm.
This multiplication is here.
Mm-hmm. That's coming. But it's easier, so that's why we leave that for last, you know? Do the hard stuff first. Yeah, way easier. So check this one out, right? So in this situation, I have a complex number. I'm gonna add two complex numbers, right? So we're going back to like day one, right? We adding numbers now, all right? So for A, here's what I wanna do. I wanna add all the real parts together. Then I'm gonna add all the imaginary parts together. And then that's the answer, right? So what's my real parts here, right? That's just the 4 plus the 5, right? What's my imaginary parts? That's the -3i plus the 6i, right? Combine them, 4 plus 5, what's that, 9? And then -3, what's that, plus 3i, something like that?
Is it?
Yep, that's it.
That's easy.
That's my answer. Yeah. Yeah. Just combine it, you know? But check this out. Check out B now. B is a little bit different, right? So for B, right, I gotta distribute that negative first. Then I can add it all up, right? So now I got the 2 minus 5i minus 5 plus 2i, right? Combine like terms. 2 minus 5, what's that? -3, right? And then -5i plus 2i, what's that? -3i. And then this is my answer right here. Not bad, right? Yeah. So eyes with eyes, numbers with numbers. That's it. Mhm. Easy, right?
Why is the negative square negative?
The -3 for which one?
The I.
So it's
Negative
net
5i.
plus 2i.
Okay.
Yeah. So the eyes with the eyes and the numbers with the numbers. Mhm. So you guys have two ways of doing it. You can either look at it and just do it the way I did it in B, or if you want to switch it around and put the reals together and the eyes together and then do it, that's fine too. Yeah, you guys try.
Plus,
Mhm. Anytime you're adding, you can just kind of forget the parentheses and then just add the reals with the reals and the imaginary with the imaginaries.
What is the sign?
This is complex numbers, adding complex numbers, this one.
change the negative to a positive. Change it if you want to distribute negative.
Yeah, it changes the sign in front of it.
Plus negative.
Mhm. Excuse me. Hey, let's take a look. Just want to add these together, right? So what's the answer for A? 6 plus 5i, very good. And what's the answer for B? So not -6. Oh, it's yeah, 6 minus 3i, very good. You got plus 3i? How? So the minus, right? Remember, you're gonna distribute this first, right? So this becomes 8 minus 4i minus 2 plus I, and then -4i plus. Huh? Mhm. You can, if you want to. You could put the reals with the reals and imaginary with the imaginary. So you could say 8 minus 2 minus 4i plus I to get this answer. That's fine if you want to do it like that. Yeah. I kind of just do it in my head. Yeah. Y'all shouldn't do that. Y'all should actually show your work. All right, now that we're done with the hard stuff, let's get over with the easy stuff. So we want to multiply complex numbers now. Good stuff, right? So multiplying complex numbers is also much like multiplying expressions with coefficients and variables. There's only one special case we need to consider. We'll look at that after we practice the next two examples. So let's take a look. This is really, really simple. It's not that bad. Oh. Exactly, right? That's exactly what we're gonna do. Just make it bigger real quick, right? So we just gonna take this and we're gonna distribute it. That's the secret. All right. All right, 14i, very good. Minus what?
Square.
Mm-hmm. 10i squared. Now we're talking, right? Oh, but here's the new trick right now, right? So we remember that I is equal to the square root of -1, right? So technically speaking, if I have I squared, right, that means that I'm just, what? For square root of -1, I'm just squaring it, right? So the square and the square root cancel out, leaving back just what? -1. So this becomes what? 14i minus 10 times -1, right? And then a negative times a negative, positive, right? So this becomes 14i plus 10, right? But you know that I want this in standard form and all that. So standard form is what? 10 plus 14i, right? And that's it. Right. So, yeah, because look, standard form is a plus bi, right? So we want it to look like that. But not bad, right? You just distribute it, boom, boom, and then that's it. You guys try.
It's going more early though, right?
It's mad easy, yeah. Probably. Probably.
Division easy.
Yeah, we're gonna get to that too. Division is just multiplication in reverse. Yeah. Yeah. Yeah, division's not bad at all. I mean, to be honest, if y'all get it, y'all can do y'all homework. Not stop, you know. It's a good water right there. It actually is.
You have to actually put it in 7 points. Just do it.
Right.
Break down, get it, the reverse.
Right. Mhm. Multiply. Right, how to model it. How to model it, yeah. So in electrical engineering, there's a lot of formulas that they have that they follow. And then they use this type of math to model electricity. Then, right. Right. That's it. Yep. The only thing is that in electrical engineering, they don't call it I, they call it J. But it's the same thing. Yeah. Square root of
What's it,
-1.
joules?
I don't know why they call it J. It probably is joules. I don't know why they call it J. But we call it I for imaginary. Huh? X? X is just some random variable. I don't know why out of the 26 letters we chose X. Yeah, I know that we can't choose I because we have this, you know, and what else can we choose? Yeah, we can't use A, B, and C because that's all our formulas. We can't use D and E because there's other formulas with that. R and S.
Alright, this is also.
R is like radius, yeah. And then which one?
Oh.
O?
Maybe it's.
It is. O would look like a degree. Yeah, there's a reason why they do all of this. Cubed. Yeah.
Cue the letter.
Like to the third. Oh, Q.
Down this form for that, right? Be crazy.
Q might be legal. Yeah, no, nobody use Q. Yeah. Yeah. Right. Yeah. Q might be legal. Yeah.
I don't think it is.
Yeah. I think that's legal. Yeah. 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 So N and M is like universal for like formulas.
So we
U,
need a measurement of the liquid.
true, if you're using the units.
Yeah.
Yeah. But I don't know. We don't take that in consideration. That's chemistry's problem. Yeah. Yeah. All right, so look, for this one, right? I just want to distribute this, bam, bam, and I get the answer. So 4i times 5, what's that? 20i, very good. And then 4i times negative 3i, what's that? Oh, negative 12i squared, right? And then I squared, we said was what? All right, so we said that I squared is equal to -1. So this is going to become what? 20i minus 12 times -1. And then negative times negative is a positive, so 20i plus 12. But you know I want this to be in standard form, so it's 12 plus 20i.
Taking points off when we do that?
I wouldn't, but your next teacher might.
Yeah, you probably.
If you could, yeah, why not? You could look at it and just tell that. That's dope. I wish I had a mind like yours. That's amazing. Yeah,
It would never be a negative. So
The count of stuff.
right?
It would never be a negative.
What do you mean? Oh, like minus 20i or something? That's possible. Yeah, that's possible.
You can't keep it a square.
Right. Yeah. Yeah, I'm sorry. Yeah, I can't have like a power on it. Yeah.
It's an I can't.
Yeah. So can we jump down to the answer with this, or we got to do it out? Yeah. So you just want to FOIL this, right? So yeah, 3 times 4, 12. 3 times -3i is what? Negative what? 9i, very good. And then now 2i times 4, what's that? So plus 8i, very good. And then positive 2i times -3i is what? -6i what? Squared. Very good, very good. All right. So let's combine like terms. What do I have? Or actually, I should take care of the square first, shouldn't I?
Yeah.
So I is equal to square root of -1. I squared, we said was -1. So this is what? 12 minus 9i plus 8i minus 6 times -1, right? Let's do our multiplication next. So 12 minus 9i plus 8i A negative times a negative is like what, a positive, so plus 6, right? And then let's combine like terms, what's my answer? Well, 12 plus 6 is what? 18, and then negative 9i plus 8i is what? Close. Negative I, right? Then that's it.
What's four, what is it?
Yeah, in the beginning of the problem, yeah. Foil
I
it,
thought it was just script.
yeah, distribute, yeah.
It's not the same.
Foil is it's the exact same thing.
No, it is.
Yeah,
Yes, you just distribute like 3 times 4.
and then 3 times negative 3i, and then 2 times 4, yeah. Yeah, foil is just like a trick to remember how to distribute. But it is distribution, yeah, you're right. This is pretty much as complicated as it gets. You guys try. I got you. I'm gonna go back up. You're welcome. Try that out. Yeah, that's coming. But division is just like excuse me, multiplication is just like divisions. Yeah, all that good stuff. Yeah, this is, yeah, multiplying them. I mean, but low key, everything that we're doing today, everybody knows how to do it. You know? Let's try this one out, right? I'm gonna distribute this 5 times negative 1, what's that? Negative 5, and then 5 times negative 2i, negative 10i, and then negative 3i times negative 1. Nope. Positive 3i, very good. And then negative 3i times negative 2i, positive 6i squared, very good. All right, let's get rid of that square. So I have negative 5 minus 10i plus 3i plus 6 times negative 1, right? Let's do our multiplication next. Negative 5 minus 10i plus 3i minus 6. And then let's get down to the final answer. What's the answer? Negative what? Switch it around, right? Negative 11 minus 7i. Because remember, I wanted it in standard form.
That's up on stuff. I just put 6i as plus 6i, because I was negative.
Got you.
Guessing.
Got you. You just plug it in and that's it. Huh? Yeah. Negative 1. Yeah, yeah. Right. Yeah. In the end, yeah. 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 I did? My
No,
fault.
stuff out where the square root.
Oh, yeah, for the square root part, yeah. Yeah. This one? Yeah. Yeah,
Oh, you did the same thing?
you just switch it. Yeah, it's not that bad. Let's look at our old buddy. Yeah, binomial squared. Yeah. So what's this gonna be?
Plus 2i.
Mhm.
Twice.
6,
Oh,
You gotta foil it.
9, right? Mm-mm. So you remember the trick formula we have, a plus b squared is equal to a squared plus 2ab plus b squared, right?
I thought you just put it in the parentheses.
You can do that, yes. If you want to just FOIL it, go right ahead. I'm not gonna stop you. But you can also use this trick too, right? This would be 3 squared plus 2 times 3 times 2i plus 2i squared. And then what does that become? It says 9 plus, what's that, 6? What's 6 times 2 again? 12? 12i plus 4i squared, right? And then, huh?
Oh,
Yeah. 2 times 3 times 2. And then this becomes what? 9. Oops. Sorry. This becomes 9 plus 12i plus 4 times -1. Right? So this equals 9 plus 12i minus, I'm about to say 5, minus 4. That becomes what? 5 plus 12i. And that's it. Easy, right? Yeah. If it looks confusing, you know how to do this, right? This is just 3 plus 2i times 3 plus 2i. Distribute it. FOIL it. Same way, right? I'm just using a trick right here. Yeah. Whichever is easiest for you. All right, just give me the right answer. That's all I really care about. Move it down. Oh, I got you. I'm sorry. The 12. So I was using the pattern, right? So 2 times 3 times 2. Yeah. The FOIL way? Okay, so, and by the way, you guys could try this if you get it. So the FOIL way would be 3 plus, oops, 2i times 3 plus 2i. So it'd be like 3 times 3, 9. 3 times 2i plus 6i. 2i times 3 plus 6i. And then 2i times 2i plus 4i squared. Combine like terms, 9 plus 12i plus 4i squared, right? Then you have 9 plus 12i plus 4 times -1, which becomes 9 plus 12i. Whoops, -1, -4, you're right. And then 5 plus 12i. So that's if you want to FOIL it. No? As long as you give me the right answer, I don't care. Then let's try this one on the bottom. A little better? Okay, that's fine. Yeah. Foiling actually works for all the binomial multiplications, so. Right. Mm-hmm. Mm-hmm. Yeah. So subtract 16 to the other side. Yeah. So now you have 0 n squared minus what's that, 26 and plus 25. All right, so now we'll factor it, solve for n. All right, let's take a look. All right. So I have the -2 minus 5i squared. I'm gonna just write this twice. Or you can use the pattern if you want to. Distribute it, right? 2 times 2, that's 4. 2 times -5i, -10i. -5i times 2, -10i. -5i times -5i positive 25i squared. Right? Let's take care of that exponent. So it should be 4 minus 10i minus 10i plus 25 times what? -1, right? And then just multiply this out. This is what? 4 minus 10i minus 10i, right? Minus 25. Now let's answer this, right? I have 4 minus 25. What's that? -21 minus 20i. Right? Everybody got that answer? You got positive for which one?
Oh, yeah, me too. Plus 20.
Negative.
Oh, wait, what was the station?
Plus 20i?
Yeah, me too.
How?
I
That's
think
so
I was
interesting.
thinking,
Oh, you know what? I actually made a mistake. There's a negative right here on the 2. My fault. Yeah, I didn't write that right. Yeah. So that's positive. My fault. Bob. Yeah, you're right. My fault. That's my mistake. Yeah. Alright. Now we good.
Vision.
Oh, nah, we're not ready yet.
Nah.
But we getting there. Getting there. So check this out. Alright. No, not doing that. So since the square root of a negative number is not a real number, we cannot use the product property for radicals in order to multiply square roots of negative numbers. We should first write them as complex numbers using the square root of negative b equal to the square root of b times I. This is one place students tend to make errors, so be careful when you see multiplying with a negative square root. All right, so let's talk about what they're talking about here. All right, let's give y'all this example real quick. All right, let's say I have this question right here, right? I want the square root of negative 36 times the square root of negative 4, right? Now you know the square root of negative 36 is what? That's 6i, right? Times the square root, well, 2i, right? And then what I'm saying is switch it to the imaginary numbers, then multiply it, right? So 6i times 2i becomes what? 12i squared, right? And we know that I squared is what again? Right? I squared is equal to -1. So this becomes what? 12 times -1, which is just -12. And that's my answer. That's it. All right? 6i? The square root of no, 36. Square root of 36 is 6. Right, so 6i. Yeah. Because 36 is a perfect square. Yeah. Like 36 times 30, no, excuse me, 6 times 6 is 36. You guys try. So switch it to an imaginary number and then multiply it.
That was a negative 30.
Mm-hmm. I know you might look at it and say like, wow, they have the same index, right? So I could just multiply the insides. But if you were to do that, a negative times a negative is a positive, and you might be tempted to just write down positive 12. It's not. It's actually -12. Right? So that's why this is the best approach. Switch to imaginary, then multiply. Mhm. Yeah. Let's do that. Yes. All right. I'm gonna try and do it tonight and then get back to y'all tomorrow. All right, let's take a look. Square root of negative 49 becomes what? 7i, right? And then square root of, right? This is 2i. And then what do we multiply them? What do we get? 14i squared, which becomes what? Which is what? Very good. Questions on that? Good. Hmm. Yeah, the I squared is just -1 and -1 times 14. That's it. All right, check this out. All right. So in the next example, each binomial has a square root of a negative number. Before multiplying each square root of a negative number, right, must be written as a complex number. So let's take a look. So here's what I'm saying, right? So I have this binomial times binomial problem here. What I'm saying is change it into the imaginary with the i's and then multiply it, right? So this first part is going to become what? 3 minus, what's this? Square root of -4 times 3. And then this is 5 plus what? Square root of -9 times 3. And just continue doing the math. So this becomes 3 minus 2i square root 3, right? And then this becomes 5 plus 3i square root 3, right? Then now FOIL it, right? So 3 times 5, that's 15. 3 times 3i square root 3 is going to be plus 9i square root 3. Negative 2i square root 3 times 5 is going to be a negative 10i square root 3. And then negative 2i square root 3 times positive 3i square root 3 is going to give me a negative 6i squared square root 9. Right? And then after that, let's simplify this, right? This becomes 15 plus 9i square root 3 minus 10i square root 3 minus 6 times, what's this, -1. And square root of 9, what's that, like 3? Let's do our multiplication. So now I have 15 plus 9i square root 3 minus 10i square root 3. This is going to be what? Negative times a negative is positive, and 6 times 3, I think, plus 18. All right. Now let's combine like terms, just add them. So 15 plus 18. Oh gosh, what is that? That is 2333, I think. Right? And then 9i square root 3 minus 10i square root 3. This looks like negative I square root 3. All right? And I'll take that as an answer. Go ahead. For the what? So basically just turn it into imaginary first, and then do your distributions, combine like terms, simplify, all that good jazz.
I got a question.
Mm-hmm.
You did the 2 square root 3, right? Or the 4 square root of -4 times 3.
Yeah, I got you.
Can
Okay.
you do 9 times 2? Doesn't work.
For 12?
Yeah.
No, but that's 18
I
though.
think 18.
Yeah. I got you. Uh-huh. Uh-huh. Oh, 3i square root 3, yeah. So -2 times 3 is -6. I times I squared, square root 3 times square root 3, square root 9. Oh, because it's -2 times +3. Yeah, like over here, this part up top. It's -2 times +3. Yeah, gotcha. Yeah, okay. Yeah, well, that's the square root of 9. Yeah. And then, yeah, yeah. Not too bad. You guys try. All right, let's take a look. Want to distribute this, right? But before I could do that, gotta change it into the i's, right? So this is gonna become 4 minus, oof, what's that? Not 2i square root 3? Just 4 times 3, and this is 3 minus, oof, what's that? 4i, and then square root 3, right? And then just distribute it. And let's see what we get. So 4 times 3, what's that, like 12? And then this is minus 16i square root 3 minus 6i square root 3. And then a negative times a negative is a positive. 8i squared square root 9. Mm-hmm. So this becomes what? 12. Oh, he's not writing. 12. Really? Microsoft? Oh, Microsoft is ODing right now. Oh, Microsoft.
Let's pick up where we left off tomorrow.
Nigga, we got a lot more left to do.
Yeah, we only got like 20 minutes left. No, we
Yeah,
got 18 minutes left.
it's alright. I can always copy and paste it back. No biggie. Oh, still here, no doubt. My fault, my fault. All right, we back at it. Let's try this again. 12. Okay, let's try it again. 12. Wow. Just gonna take my pen from me and everything. 12. All right. Cool. Minus 16i square root 3 minus 6i square root 3 plus 8 times, right? Times 3. Very good, right? Do the math on this. This is 12 minus 16i square root 3 minus 6i square root 3. What's this? Minus 24. Let's combine like terms. What we have now? Negative 12 minus 22 I square root 3. Am I right about that? All right. And then that's it. That's our answer. Yeah. Up here. So this is, got you. So the 6i is this one, negative 2i square root 3 times 3. That's a negative 6i square root 3. Right. Right. Yeah. So you just multiply like the numbers together and then that's it. Yeah. Yes. All right. In case y'all want to see. Almost ready for division. Not there yet, but we almost there. All right. Tomorrow we on to bigger, better things, man.
Like what?
Oh, like math formulas.
Oh, that's what you meant by very.
Yeah.
So you tomorrow.
Yeah. All right, so we first looked at conjugate pairs when we studied polynomials. We said that a pair of binomials that each have the same first term and the same last term, but one is a sum and the other, and one is a difference, is called a conjugate pair, and is of the form a minus b and a plus b. A complex conjugate pair is very similar. For a complex number of the form a plus bi, its complex conjugate is a minus bi. Notice they have the same first term, same last term, but one is a sum and one is a difference. That's it, right? Right. For the same reason that we have from yesterday, right? It's illegal to have i's in the denominator, right? Right, because that's a radical, and radical is not allowed in the denominator, right? So complex conjugate pair. A complex conjugate pair is of the form a plus bi and a minus bi. All right. So let's take a look. So let's say that I have this complex conjugate pair right here, right? 3 minus 2i times 3 plus 2i. You already know what's going to happen, right? I'm going to distribute 3 times 3 is 9. 3 times 2i, this is plus 6i. In the middle, this is going to be minus 6i. And on the end, excuse me, negative 2i plus 2i is negative 4i squared, right? Let's take care of that, right? So I have 9 plus 6i minus 6i minus 4 times negative 1. right? Right, now let's do a multiplication. 9 plus 6i minus 6i plus 4, right? Let's combine like terms. 9 plus 4 is what? That's 13. And then these two just cancel out, right? So that's my answer, 13. All right. Nope, no I. It's positive 6i minus 6i. That's just 13. Right? Easy, right? No. Huh? Is it wrong?
What was that?
Mhm. I got you. Try it out. So you want to see the whole thing? Gotcha. You're welcome. So try this out, you guys. Nothing crazy, just distribute, combine like terms, blah, blah, blah. But let's try it out. 4 times 4, 16. 4 times 3i, this is plus 12i. Negative 3i times 4, negative 12i. Negative 3i times positive 3i, what's that? Negative 9i squared, something like that, right? And we're going to have 16 plus 12i minus 12i minus 9 times negative 1. So what does this become? 16 plus 12i minus 12i plus 9, right? Let's combine like terms. These cancel out. So 16 plus 9, what's that? 25. And then that's it. All right.
That doesn't always have that behind.
In this situation, when it's a complex conjugate, they don't have eyes, right? So like you see how this one is like a minus and a plus, and they have the same beginning number, same end number? That's a complex conjugate. Yeah. If they're different, then it's not the same. All right. So from our study of polynomials, we know that the product of conjugates, is always of the form a minus b times a plus b is equal to a squared minus b squared, right? The result is called the difference of squares. We can multiply a complex conjugate pair using this pattern, right? So check this out. About to make this super easy right now. Super, super easy. All right. So when we multiply complex conjugates, the product of the last term will always have an I squared, which simplifies to -1. So a minus bi times a plus bi becomes a squared minus bi squared, or a squared minus b squared times I squared, which will become what? A squared minus b squared times -1, or a squared plus b squared. So this leads us to the product of complex conjugates pattern. So when you have a minus bi times a plus bi, it's going to be equal to a squared plus b squared. That's the shortcut right there. That's the shortcut. All right? Just to drill it home a little bit. Right here, the product of complex conjugates. If a and b are real numbers, then a minus bi times a plus bi is equal to a squared plus b squared. All right? All right, so now that y'all know the sauce, right? Y'all got it all down packed real quick. What's the answer for this? Right?
Square.
Right? So it's gonna be 8 squared plus 2i squared, right? Well, not 2i squared, technically it's just 2 squared. You could just drop the I and just do it like that. So 64 plus 4, 68, done. When it's a complex conjugate pattern, right? That's all it is. So real quick, what would you say the answer to this is, or the process? Give me the process. This would be what? 3 squared plus 10 squared, right? And 3 squared is what? 9 plus 100, which equals 109. That's tomorrow's temperature, right? Oh, I'm sorry. Right. All right, now we ready to get to the meat and potatoes now. Now we ready. All right. So we're gonna divide complex numbers. Here we go. All right. So dividing complex numbers is much like rationalizing a denominator. We want our result to be in standard form with no imaginary numbers in the denominator, right? So it is illegal to have imaginary numbers in our denominator, just like it is illegal to have radicals in our denominator, right? Same thing. So let's take a look, right? Let's say I want to divide 4 plus 3i divided by 3 minus 4i, right? All I got to do, I have 4 plus 3i over 3 minus 4i. I'm going to multiply this by the conjugate. So this is going to become 3 plus 4i. But what I do to the bottom, do to the top, 3 plus 4i, right? And then distribute. You already know, right? So the top is going to be what? This is going to be 12 plus 12i plus, what's that, 9i. Yeah, well, the end of it is 12i squared, right? Yeah. And then for the bottom, we already know that trick, right? So you already know this is what? This is 3 squared plus 4 squared, right? Bam, we got that trick right there, you know? All right, let's take care of that square at the top, the combined like terms, all that good stuff. So this is going to be 12 plus 12i plus 9i plus 12 times -1 all over what? What's this? This is like 9 plus 16, something like that. Combining like terms, doing multiplication, all of it at once. So this is 12 plus 12i plus 9i minus 12 all over, oh gosh, what's that? 25, something like that. And then combining like terms at the top, what I got? Oh shoot, 12 and 12 cancels out. What's this? 19, 20, 21. So 21i divided by 25, something like that. It's not bad, right? Yeah. Gotcha. That's dividing right there. That's that division. Yeah. 12i supposed to be 69? Which one? You're right, that is 69. Whoops.
Taking a picture of the wrong answer.
Right? My fault. Yeah, so that's 16. So it happens when you're rushing. 16, right? So this is, right? So then that should be -4, right? So -4 plus this. That's the right answer. -4 plus 21i over 25. That's it. Yeah. Good catch. Thank you. Wait. Hold up. Wrong one. That was the wrong one. Hold on. This is the 16. My
Yeah,
fault.
that's two places.
Wait, that's the 16. My fault. And this is 12. My fault. Hold up. This is the 16 right here. Nah, because the last one is 3i times 4i. That's 12i squared. Yeah. But you're right. The hell? The four times the 4i, right? That's the 16i. My fault. Good catch. So 25i. Mm-hmm. No, you wouldn't have the -4 there. Yeah. But actually, you know what would happen here? 25 divided by 25, right? That's just I. So that's the right answer. Yeah.
No, thanks, you know.
That was a good one. Not gonna lie, that was a good one. All right, so basically we get this process, all right? Let me just give y'all the notes on this real quick. So how to divide complex numbers, all right? So step 1, write both the numerator and denominator in standard form. Step 2, multiply the numerator and denominator by the complex conjugate of the denominator. Step 3, simplify and write the results in standard form. All right? And that's how to divide complex numbers. Sure, no problem. Here or make it smaller. All right. All right, I still got 2 more things to show y'all real quick. And then we could call it at that. So I just need like maybe another 10 minutes real quick.
10 minutes?
Yeah. It's not bad though. I'll be quick with it. I'll be quick. All right. So on your homework, right? You might see an example that looks like this real quick. So look, you might have an example that looks like this one, where they ask you to divide 5 plus 3i over 4i, right? So let's talk about how we're gonna do this one now, right? So I'm gonna rewrite this. Right? So this is gonna become 5 plus 3i, right? But check this out. Watch what I'm doing to the 4i. This is gonna become 0 plus 4i, right? So now this looks like what we had before. So what's the conjugate of this one gonna be? 0 minus 4i, right? And what I do to the bottom, I do to the top. 0 minus 4i. Now distribute and do what you know how to do, right? So 5 times 0, 0. 5 times -4i, -20i. 3i times 0, 0. And 3i times -4i is going to give me a -12i squared, right? All over, you already know this is what? 0 squared plus 4 squared, right? Let's combine like terms, get all this all this good stuff going. So I'm gonna have negative 20i minus 12 times negative 1 over 4 squared, right? Let's do the math on this. This is gonna be what? A negative times a negative is positive, so I'm gonna have 12 minus 20i over 4 squared, which is what? 16, right? Now, technically what I should do 12 over 16 minus 20i over 16 and reduce them individually, right? So for 12 in this, like, let me think, 4 goes into 12, I think 3 times, and 4 goes into 16 4 times. So 3 over 4 minus, and then let me think. Well, 4, right? 4 goes into 20, I think 5 times, right? So it's like 5i.
Oh,
Yeah, 5 times 4 is 20, right? So yeah, 5i is left over and then 4. So this should be like what? 5i over 4. So yeah, that would be my final answer. Or you can write it as 3 minus 5i over 4, since they have the same denominator. So I would take either one of these answers for that, right? That might be helpful to you on web work, right? I'll make it smaller in case you want to take a picture or anything. So that's the trick, right? You don't see no real number there, write a 0 in place, just so you know to use the complex conjugate. All right? All right, last thing, right? This is going to be on your test and it will be on the final. So pay close attention to this next one. Nope, this next topic right here. Right? So I want to simplify powers of I, right? We're simplifying powers of I. So the powers of I make an interesting pattern that would help us simplify higher powers of I. Let's evaluate the powers of I to see the pattern. So I to the first power, we know is just I. I squared is equal to -1. I to the third power becomes I squared times I, or -1 times I, which is -I. I to the fourth power is I squared times I squared, which is -1 times -1, or +1, right? Now look at this. When we go up to higher powers, this pattern repeats. I to the fifth power is I to the sixth power is -1, I to the seventh power is -I, and I to the 8 is 1. The pattern constantly repeats in 4s, right? That's what I want you all to see, right? So just to summarize real quick, right? Just to summarize real quick. Whoops. All right. So if I have I to the first power is equal to I to the second is equal to -1, I to the third is equal to -I to the fourth is 1, I to the fifth is I to the sixth is -1, I to the 7 is -I to the 8 is 1. All right.
so every 4 i's is positive 1.
Exactly. They just repeat in 4s, right? Everything. All right. So if we continued, the pattern would keep repeating in blocks of 4. We can use this pattern to help us simplify powers of I. Since I to the fourth power is 1, we rewrite each power I to the n as a product using I to the 4 to a power and another power of I. We rewrite it in the form of I to the n is equal to I to the 4 raised to the q power times I to the r, where the exponent q is the quotient of n divided by 4, and the exponent r is the remainder from this division. For example, to simplify I to the 57th power, we divide 57 by 4. We get 14 with the remainder of 1, right? So in other words, 57 is equal to 4 times 14 plus 1. So we write I to the 57 is equal to 1 to the 4 power raised to the 14, and we know that that's just going to be 1, right? Times the remainder, which is I to the 1, and then simplify from there, right? So, this is what I'm saying, right? So if we take 57 divided out, right, by 4, oops, I think I made that a little too big. Hold on. All right. So we take 57 divided by 4, we're going to have 14 with the remainder of 1, right? And we always like subtract right here, right? And y'all know how to do that, right? So 57 can get written as 1 to the 4 power raised to the 14th power times I, right, to the 1 power. So then that leaves me with just 1 times I, or I, as my final answer. So we're going to have questions where you're going to have I to some random power, right? And then you're going to simplify it down, and it's either going to be one of 4 answers, right? It's either going to be I, it's going to be I squared, it's going to be I to the 3rd power, or it's going to be I to the 4th power. One of those will be your answers, right? And you remember that I squared is -1, I to the 3rd power is negative I, and I to the 4th power is equal to positive. So for example, let's take a look at this, right? Last example. Let's say I have I to the 86th power, and I want to know what is that. I don't know what that's going to be in the what you call it, in the 4-way pattern that we have, right? So what I do is I take the 86, right, divided by 4. 4 goes into 8 2 times. 2 times 4 is 8. Subtract that 0, bring down to 6. Now 4 goes into 6 1 time, and 1 times 4 is 4. Subtract that, that's 2, right? So that has a remainder of 2. So I can write I to the 86th power as what? I to the 4th power, right? Raised to what? The 21 power, right? Times I to the remainder, which is 2. This whole first part becomes 1 times I squared. So my final answer is just what? I squared. And that's it. And what is I squared equal to again? -1. So that's it. So that number right there could be any number, right? It could be 52, 57, 65. What year is this?
24.
All right, it's 2024. Could be anything, right? All you gotta do, divide by 4, and whatever the remainder is, put that on top of the I, and that's the answer. That's it. All right? Y'all will see this on your test. You will see this on your final. I'm not sure if you're gonna see it for your homework.
Well, for the final, just give me like 5, 6, 7, 8.
It could be some random number, I don't know. Yeah, go ahead. Yeah, I got you.
Can't count about 10 with me.
Yeah, that's the issue.
Oh my God, that is crazy.
Yeah. Yeah. They got high imaginations when it comes to the numbers, you know.
That's crazy.
They might just add all the ages together and be like, yo, I to the. Yeah. I got you. Yeah. This chart or the one above? I see you, man. All right. See you, man. Who? Oh, you. Well. Oh, not for you. I didn't finish it. I'm gonna try and do it tomorrow. Try and do it tomorrow. I got you. Yeah. Oh, y'all finished? I could take this out?
Did I
I
see the-
appreciate that. Which one?
The district we did for 86.
Oh, sure. See y'all. Alright, go ahead. Alright, man, I see you. Have a good night. It wasn't bad, actually.
I noticed, some numbers,
Yeah,
I had it.
yeah.
Put it wrong.
Like you low-key had this one.
Yeah, I had it right there, but I
Yeah.
scribbled it out for some reason. and I ended up
Yeah.
putting this-
Yeah. It's alright, it's all good. Alright, let me just have a good night, everyone. See y'all tomorrow.